Chapter 16, Solid and Hazardous Waste. Think about the number of automobiles that are used just in the United States alone. Certainly we always have recycled parts of automobiles, but ultimately that still generates a lot of solid waste that has to be disposed of every year. About 11 million vehicles a year are discarded in the U.S. Up to 75% of a car's parts can be recycled or reused, but about 25% of every car ultimately ends up in a landfill somewhere. The glass, some of the metals and plastics, rubber, fabric, etc. About 37% of the iron and steel scrap that's reprocessed in the United States that can be then reused into other manufacturing processes comes from old cars. So again, over a third of the steel and iron scrap that's reused in the United States comes from old cars. And as with most things, when you are able to reuse or reprocess, in this case, material, generally that creates a lot less air pollution and water pollution than actually mining the raw materials and then refining them to an equivalent amount of ore that would be used to create that material. So again, clearly reprocessing that material not only creates less demand on that resource, but certainly creates less air and water pollution. In Japan and the European Union, by 2015, so just in the next year or so, 95% of each car must be recycled or recovered in some way so that it doesn't end up in a landfill. Probably won't be very far behind that as far as the United States. So when we're talking about solid waste, we're talking about pretty much any material that would be thrown away that again comes from products we use. So basically the U.S. as a most developed country and the amount of consumption, you probably would guess that we also therefore generate a lot of solid waste, more than any other country. It averages about 2 kilograms per person per day. Canada's a close second. So again, that's close to 5 pounds per person per day. This would be everything from the cardboard cereal box that's empty that you recycle or maybe throw away instead of recycling it. All of the packaging that comes with pretty much every product we buy. And then again, all the other stuff, electronics that we throw away when they no longer work. Electric can opener that quits working that we throw away instead of disposing in some other way. Again, since highly developed countries are the ones that consume the most resources, it makes sense that basically they produce the most waste. Keep in mind, though, that a lot of the materials we throw away would actually be repaired, typically electronics. In this country, if the DVD player quits working, it's just as well. We throw it away because we want to buy a Blu-ray, or we throw it away because we want to buy a better version. If the TV quits working, we throw it away instead of fixing it. When the computer starts getting a little too old, we throw it away. But again, in other countries, the less developed countries, they'd repair those things. Or, cars end up staying on the road a lot longer because they're repaired and they're used much longer than typically occurs in a developed country. So again, basically they sort of have no choice, because it's an economics thing. They can't afford to buy a new car or a new computer every few years. Look at some of the types of solid waste now. There's basically the category of municipal solid waste and then the non-municipal types. Municipal types are basically when we look at all residential structures, so the homes and apartments that we live in, and that also includes the commercial waste that's produced by a municipal area. And that's actually less than about 2% of the total waste. And again, this includes any solid material that's thrown away by homes, offices, stores, restaurants, schools. You can read the rest of the list. Again, most of the items here that we're talking about, what tops the list are typically paper and paperboard type materials like cardboard. Then things like yard waste, people that bag the grass clippings when they mow their lawn, or stuff you might prune around the house, plastics, food waste, metals, and typically it's the metals other than maybe aluminum that there's a pretty good amount of money you can make from recycling it. And then again, pretty much anything else you can think of: rubber, leather materials, textiles, wood, glass. But again, all of those items account for less than 2% of all of the solid waste. Typically, it's the non-municipal solid waste, the byproducts that are generated by industry, all of the manufacturing byproducts, the byproducts from agriculture and from mining that account for the vast majority of the solid waste. Again, those are the non-municipal products. If you look at a pie chart that kind of shows the total composition, mining far and above outweighs any of the other areas. Agriculture is a distant second, followed by industry. And then if you look at that 2% or less expanded out, as I mentioned, it's the paper and cardboard type products that account for the majority of municipal waste. And again, the thing here is that often most of that is recyclable. It's just that a lot of people think of that as being more of a hassle to keep it and then recycle it. But then things like yard waste, food waste, plastics all account for double-digit percentages: metals, rubbers, textiles, wood, glass, and then all of the other things account for just about 3%. Again, notice the food waste. 14% of all solid waste that we throw away from our homes and in businesses is food waste. Now, obviously, some of that makes sense. The bone from a cut of meat, unless you give it to your dog. If you have a dog, that's not edible. It's not even compostable if you're into composting. Could be the skin from bananas or oranges, but unfortunately there's a lot of that waste that is actually still edible food. Waste from restaurants of uneaten food, stuff that we put in our fridge and forget about until it turns green. So a lot of stuff there that could be used gets thrown away or wasted, along with plastics, some of which are recyclable, and people just throw them away anyway. It was typical in less developed countries and even in developed countries in the past that we basically just used the old-fashioned method of a dump. There would be a place where a hole would be dug in the ground, and then the trash would simply be dumped in the hole and eventually covered with dirt, and then a new hole would be dug. This is basically illegal now in our country. It's not a sanitary method, and we'll actually talk about what sanitary landfills are, which is the standard now. But having that trash and garbage in these open holes would be, create a lot of odor issues for anybody nearby, because that stuff was just exposed. Rats would get into it, birds, flies would be a problem. Certainly, as organic matter that was dumped in the landfill decomposed, it would emit methane gas, and then all of the other toxic stuff that was in that waste. Think of things like the old-fashioned batteries. Car battery would die, you'd dump that in the landfill, or the batteries from your flashlight, just throw those in the garbage, and then as they break down, they give off a lot of toxic stuff. And because these were just holes in the ground, those toxins would leach out into the soil, and they could easily get down into the groundwater and then obviously create some contamination issues. It was also pretty common that a fire would be used as a way to break down some of these things. Tires were burnt in the past. They would just be stacked up, and then eventually they'd be lit on fire and burnt. Some of the worst looking air pollution that you could ever imagine comes from burning tires. And so then again, lots of nasty stuff seeped into the environment and released into the air in these old types of landfills. So because we finally identified that was a kind of a not great way of getting rid of our trash issues, we were able to design what we use now, which are called sanitary landfills. Basically, these are still holes in the ground, but the hole is then lined with a variety of materials and things that basically will keep whatever's in that landfill from leaching into the environment. And then daily, the waste that's dumped in the landfill is compacted and buried under a shallow layer of soil every day. So that keeps the odor down, it keeps the animals from being able to get into it. So again, just overall a much, much better way of dealing with solid waste. There are still waste products that are incinerated, that are burnt at high temperatures to reduce the volume of the waste product by up to 90%. Not every solid waste product is or can be incinerated. We certainly don't want to incinerate things that are going to release toxins. But the yard waste, the wood type waste products can safely be incinerated. And then anything you can do to reduce the volume into a landfill is going to prolong that landfill. Certainly one thing that almost all of us can do at home is composting. Instead of throwing all that food waste in the garbage or the yard waste, it can be converted into compost that you could use on your house plants to keep them healthy. Don't have to use fertilizer. Even if you have a small yard or an apartment, there are ways that you can compost material. And even if you don't have a use for it, maybe your neighbor does, putting in their flower beds or in their potted plants. So again, kind of notice the figure here. Materials are discarded into the landfill, about 54% of the materials, 11% are burnt, incinerated, and actually we're able to generate some energy by doing that. And about 34% are recovered, and then again, reused, remanufactured in some way. So as I mentioned, the current sanitary landfills replaced the open dumps of the past. They get about 54% of the municipal waste. And again, much of that is waste that could be perhaps recycled or in some way reused by the people that throw that stuff away. And again, basically these sanitary landfills use a liner at the bottom, things like plastic liners, compacted clay, plastic, and then more clay. So it's a multi-layer system that, again, it's designed to keep stuff as it decomposes from leaching into the soil and eventually getting into the soil. And so then that material that's called leachate is actually collected in the landfill. And again, it's not allowed to get into the soil anymore. And then even those gases that are produced by the decomposition of organic material are either collected, vented to the surface if that's feasible, and even sometimes in large areas that methane can actually be burnt to make energy. So even though there are strict guidelines to how these things are made and how they're managed over time, there certainly are still problems. These things basically, once they're full, they're covered over, buried permanently, but plastics and clays and other materials probably will not last indefinitely. So there are times when leakages can occur. So even when these areas are done and abandoned, we still have to monitor them and have a plan if a leak were to develop. So again, this diagram just kind of shows you what a sanitary landfill looks like, kind of how it's operated. Notice that pipe where the methane gas is vented, where again it's either burnt off just to get rid of it, or even converted into energy. Plastic is one of those products that's become so common in our modern society. Just about anything you ever buy is contained in some amount of plastics, plastic packaging that is used to ship it. And the problem with a lot of that plastic is that it's not the types of plastics that can be easily recycled. The amount of plastic also in our waste continues to grow. More and more of the products that are sold are created or packaged in plastics. Plastics are relatively stable products. Chemically, they don't degrade very easily. And so they tend to stick around for a long time. If plastics get, dumped into a landfill, they're pretty much going to be there forever. Plastic materials that just get dumped on the side of the road, if they weren't going to be picked up, they'd be there basically forever. Some types of plastics have actually been banned. The PVC type plastics, the polyvinyl chloride type plastics have been banned, at least partially because of the process that's required to make them creates lots of byproducts that can be pretty hazardous. And those types of plastics, when they degrade in the environment, can create lots of nasty stuff. But again, while some plastic is recyclable, most typical sort of soda bottles or water bottles, most of the plastic that's in the packaging for all the other products we buy doesn't tend to be the types of plastics that can be recycled. So we have been developing alternatives, plastics that are photodegradable, that break down when they're exposed to light. But of course, if these plastics are dumped into a landfill and buried with soil, they aren't going to degrade because they're not exposed to light. And then there are those that are biodegradable. So these kinds of plastics, even if they're, exposed to the environment, they will break down naturally. But research is also showing that they don't readily break down in a landfill. Any thoughts why that would be? Do they need light to break down if they're biodegradable? What does life need? It needs oxygen, right? So basically, if you're in a anaerobic condition, so buried under soil, the microorganisms can't live in that condition to actually break down the plastic. So while these are good options in some cases, if they still get put in a landfill as opposed to recycled or something else, they're still not going to degrade. So again, there are items that can be effectively incinerated. The benefits of that is that we're reducing the volume of waste. By burning something, it reduces the volume. And then that energy can be used to produce heat, which can be used for heating buildings. Again, back in the old days, apartment buildings would have boilers in the basement. All of the trash in the building would be burnt in the boiler, and that boiler would be used to heat water that would be circulated through the building for heat. And again, that's a great idea, and we're trying to get back into doing those sorts of things. But the problem is that back in those times, the boilers didn't have any kind of technology to remove any pollutants that would be generated. So people would burn basically anything that was in the garbage, and some of that stuff could produce some nasty pollution. Typically paper, obviously, is a good candidate for burning. Plastics, if they're burnt, combusted at high enough temperatures, and if there are scrubbers that can remove some of the toxic elements, that works. Rubber, glass, and food waste, though, generally need to be removed, and incinerating those items just doesn't work. There are waste-to-energy incinerators around the U.S., about 87 of them as of 2011. Certainly this is something that's been talked about more, creating more of these incinerators, biomass plants. Could be used to burn wood, the stuff that's left over from logging operations, or when cities go around trimming trees, as well as burning other municipal waste. We've got the cogeneration plants around, like Wheelabrator, and basically they burn a variety of items and are able to generate energy. So it's certainly something that we could utilize a lot more than we do. But typically the reason we don't is because there are issues with air pollution, the production of carbon monoxide, particulates. Again, people will throw away things they shouldn't. Batteries, for example. So if you miss it and a battery gets put into an incinerator, then you can have toxic materials released. Even then, when this stuff is combusted, even though it's reduced in volume, it does create large amounts of ash. And basically that ash needs to be disposed of in a hazardous waste facility. At that point, it's considered hazardous waste. And so, these kinds of waste-to-energy incinerators can be a little bit expensive because of how much it costs to control pollution, and because they typically have to pay to get rid of the ash. Again, they can't just go dump the ash somewhere. It has to be disposed of in a sanitary landfill, and usually that costs money. So here's a diagram that kind of shows the process for these waste-to-energy incinerators. from a receiving area to feeding the furnace to sort of capturing that energy to then how the hazardous materials are extracted and stored. I mentioned that composting is something that probably every one of us could do to a degree, whether we have a home and a yard or even those of us that live in apartments. When you look at the amount of yard waste alone that's generated, there are certainly better options for dealing with that, and that would be composting. If you live in a place where you generate yard waste, then by theory, by definition, you should have enough space to be able to compost it instead of throwing it away. The best recovery method is to basically convert that yard waste back into compost or mulch that can be used to put back on your lawn or back in your garden or back in your flower beds. And then again, if you have space, you can compost most food scraps. In the ag industry, a lot of the manure or waste products from growing food is actually composted and spread back on ag fields. Sewage sludge from sewage treatment facilities can be treated and composted and reused, although some of that also does have to go to landfills because it can and does contain toxins. Places like most cities now, the city of Reading, for example, all the landscaping in the city parks, the mulch and things that they utilize are from the compost that the city itself generates when they prune trees and that kind of stuff. They even typically will offer it free back to the residents of the city if you have a need for compost or other bark mulch, that kind of stuff. And so it has a lot of uses. The book mentions about it being sold to gardeners, which is certainly true in some areas, but again, a lot of cities will actually give it to people because they oftentimes generate way more of it than they can even use. This might be something that you would think kind of started in the U.S. like other things, but this actually really started in Europe. A good guess would be that, again, places like Japan, it's an island. It's not that big, really. And so they have to become way more efficient at recycling and doing things to conserve space. So as long as Europe's been inhabited and utilized, again, sometimes those kinds of places are forced to be the innovators. When you don't have seemingly endless land to keep making more landfills like we do in the U.S., you've got to come up with better alternatives. And so this is one of those cases where, one of the many cases where other places in the world have been the pioneers for ideas that are now, maybe much more common. So ultimately, the better option is not to figure out what to do with the waste once we've created it. The better option is to deal with how do we minimize or prevent the waste from even being created. So basically we're looking at how can we reduce the amount of waste as much as possible. And again, when you're talking about places like the United States where we consume a lot of resources, requiring and forcing our manufacturers to use less packaging, and even packaging that can be reused or repaired, makes a lot of sense as opposed to making so much of it disposable. Ultimately, that has to be the first step, but then certainly decreasing the consumption of it. So if there's less demand and if the products are packaged in a more conservative manner, those two things alone are really going to be the key to our future. Reusing products as much as possible, recycling products as much as possible. And again, that really has to start with every one of us. Every time you go to buy something or think you need something, ask yourself, do I really need this? Do I need a new computer just because mine's 2 years old now and there's a better one out there? I mean, I think the answer to that question would always be no. But again, asking yourself, do you need this product? But then the other thing, packaging of some products is just ridiculous. They've been doing a better job, some companies, but it used to be, you might go to a place, electronics store, and you want to buy a memory card for your camera. And the memory card would be packaged in a big chunk of plastic, and then there'd be a cardboard insert that had, all the labeling on it, and then there'd be making up a number, a 1,000-page user manual. I'm making that up, of course, but there'd be a piece of paper that's written in 7 different languages on the instructions on how to insert the user card, the memory card into your camera. Those are the kinds of things we need to write the manufacturers about and tell them, we don't want to buy these products if they're excessively packaged. And again, there are some companies that are doing a better job of that, but I bet if you go to a place like Best Buy or other electronic stores, or you think about the last time you ordered anything, just think about how much packaging it came in. I had ordered the digital camera that I've had forever, probably 10 years ago, and when I got it, it was in a large cardboard box. I mean, way larger than the camera was, which I thought was odd. You open up the cardboard box and it's full of those styrofoam peanuts. Fortunately, now more manufacturers are using the starch ones that are biodegradable. And then inside of that cardboard box full of peanuts, there was a plastic, container box sort of thing that had the box of the camera inside of it. And then again, you open up the camera box and there's all kinds of things in there. You have to unpack the camera when you buy a television or some other large appliance. There's foam inserts that keep it stabilized. There may be bubble wrap wrapped around it. Just lots and lots of things that end up just getting thrown in the garbage that fill up our landfills. I like this little cartoon on the bottom of the screen here. It's just this guy going to the landfill to throw away some garbage and, looking at the tricycle and the electronics and those kinds of things, and just makes the note that, you can see how spoiled a society is by what it throws away. We're pretty spoiled as a society if we throw away a 3-year-old computer that another country would probably keep and use for 10 years. We're spoiled because we can afford to throw it away. Does that mean we need to or we should because we can afford to buy a new one? Again, that's a question every one of us needs to ask ourselves. So again, ultimately, reducing the source of the solid waste is the key. And so, having products that are designed and manufactured in ways to decrease the amount of solid waste, either that's produced in making them or that results when those eventually have to be thrown away. Aluminum cans are lighter now than they were in the 70s. They're thinner, meaning they use less aluminum. So we're saving aluminum by simply not needing as much to make a can. Also, this idea of dematerialization, making things smaller and more durable than they were, so that, again, we're reducing wasteful products. Some of you geeks might have thought that has something to do with Star Trek, being able to dematerialize things. I guess you could almost argue that that's kind of how we are as a society. We think that things that are no longer in our sight are literally dematerialized, like on Star Trek. They go away. If we don't see them, they're gone. They don't exist anymore. But again, we know that's not true, or hopefully we know that's not true. Everything goes somewhere. And just because we don't see it doesn't mean it isn't filling up a hole in the ground somewhere or creating pollution. So reducing the source, obviously that's a huge part of this. But then also not only making things that are more reusable, but also reusing things that we currently utilize. Making glass bottle beverages that are refillable. Recycling is good. Recycling glass is better than making new glass. But being able to sterilize and reuse a glass bottle is still far better than all the energy it takes to remelt that glass and reform it. I don't see hardly any of that in the U.S. that I'm aware of. I know it's a little more common in other countries. And again, why is that? Well, I think ultimately it's because it's inconvenient for us. It's easier just to throw the glass in a pile and not worry about it breaking from when you throw it away to when it gets to a facility. If it's not convenient, it's something we just don't want to take the time to do. It's inconvenient to stack up our papers for a week or a month and then have to haul them somewhere to recycle them. It's easier just to throw the daily paper away. So again, it ends up being kind of a lack of convenience that creates the problem for a lot of us. We just don't want to make the effort to do these things. So again, we know there are a lot of materials that can be collected and processed, reprocessed into new things. And this generally always conserves energy more than if we were to throw an aluminum can away and then go and dig more aluminum ore out of the ground and make a new can. For example, the book cites that for every ton of paper that's recycled, that saves about 17 trees. And then maybe even more importantly, since the trees will grow back, it saves thousands of gallons of water that are needed in the process of making paper. Lots and lots of energy that creates air pollution and depletes non-renewable resources, and about 3 cubic yards of space in a landfill. So just paper alone, the amount of non-renewable resources that are utilized in making paper is huge. So for every bit we save, we're saving a little bit of resources. In 2010, the rate of recycling aluminum and then other typical things like steel cans, plastic bottles, glass containers, newspaper and cardboard averaged about 557 pounds per person. So again, that's per year. And overall, we recycle about 34% of our solid waste. I don't know if 550 pounds seems like a lot or a little. I think of every week when I push my recycling container out to the road, I'd be surprised if it weighs less than 30 pounds a week, maybe more like 50 pounds a week. So, you multiply that across the board, that could be right around the average, maybe less or more. I guess it depends on what items are recycled. Obviously, glass weighs more. We don't buy a lot of glass, I've noticed. We don't really use a lot of aluminum containers or glass containers. Most of our waste tends to be plastic bottles to a degree. And then a lot of it's just the cardboard and the packaging that food comes in. So I guess, again, it depends on how much aluminum or steel or glass you use as to how much it actually weighs. So I was just thinking, if it's 50 pounds a week for me, that's only about 250 or 300 pounds a year. But then again, if we don't use a lot of glass or aluminum or steel cans, so whatever. Interesting thing here is this figure shows, again, the millions of tons of items that are recycled on the top half of the graph, and the amount that's actually incinerated or dumped into a landfill. And again, you notice for everything except for aluminum, wood, the stuff on the far end, aluminum, wood, textiles, leather, and then whatever's in the other category, the paper, yard trimmings, food scraps, plastics, glass, the metals like iron, steel, nickel. Far more of those materials are still thrown in a landfill than are recycled. Even though it's not much, but you can get a little bit of money for glass and plastic and metals. Or again, even if you have a recycling bin, it's going to get reused, even if you don't make any money off it. Compared to, again, aluminum, where you can make money on aluminum more than any other recyclable material. So again, it's still, even though a lot of these things are recyclable and we have the option of just having a garbage can that is now a recycling can, just push, you just fill it up. You don't have to separate things. You just fill it up and throw it out in, or, put it out to the curb. A lot of people still just don't make that effort. I had someone, this almost made me feel like a failure as a teacher. Walking out of the environmental science class one day, the face-to-face class, and someone ahead of me walked right past the recycling can and put their plastic bottle in a garbage can. So it's not even that there wasn't a recycling bin, and somebody just, it's too inconvenient, I'll throw it away. They walked right past the recycling bin to throw away a plastic bottle. So again, clearly my guess is that person and their family, their parents, just didn't recycle at home, so it wasn't a part of their reality. It's one of those habits. It's either a habit you develop or don't. And so even talking about it wasn't enough to really make that person aware. Paper currently is recycled at a rate of about 72%. Again, despite how much is still getting thrown away. Compare that, though, to a country like Denmark, where they're very close to 100%. Recycling glass, about 33% in the US. Even though it costs less to make glass, and this is the reason, it costs less to make glass from virgin materials. So the manufacturers aren't really interested in using recycled glass because it costs them more money to do it that way. It used to be that was the case with aluminum cans. It was cheaper to dig it out of the ground and start from ore than it was to recycle it. Now I guess that it's actually cheaper to use recycled aluminum, but it's still cheaper to use raw materials to make glass. Otherwise, then the recycled glass, basically it's crushed to make what's called cullet, and then from that cullet, new things are made. One of the inconveniences with glass, of course, is that although clear glass can be mixed with anything, the brown or the green or any other colored glass has to be separated. And so if a batch gets contaminated with multiple colors, it basically can't be used because nobody is going to go through fragment by fragment and separate out the green and the black and whatever other color. Again, aluminum is clearly the best success story in the United States with respect to recycling metals. About half of all aluminum beverage containers are recycled. Again, that still seems amazingly low to me, given that aluminum is worth a fair amount of money per pound. And again, in the case of aluminum now, it's actually cheaper to use recycled aluminum than raw materials. We look at the graph there where we compare glass with aluminum. The red bar is where it's used once and then basically disposed of versus recycling. And then again, what we're comparing there is the amount of energy. So clearly at this point, it takes a lot more energy to basically make an aluminum can, use it once, and then throw it away, compared to being able to recycle it. There are a lot of other things, though, that are definitely recyclable. Lead, gold, iron, steel, silver, zinc. And you're probably thinking, well, holy crap, why would anybody throw gold away? But any of you tech-savvy people, there are a lot of precious metals that are used in making electronics. The challenge in the recent past has been kind of an issue of recovering it. You know, there's not a lot of gold in an iPhone, or there's not a lot of some of these other materials in a computer. And in order to recover it, you gotta tear the thing apart just to get little bits of these materials. So it was never really worth the effort to do it before. It didn't pay to do all of that, tearing apart just to recover little bits of material. And so again, it just wasn't feasible before. Now we do it more because we don't want to dump that stuff in a landfill where it could create toxins or let it go to waste. Now it's pretty typical that things that are made out of steel contain about 50% recycled steel, scrap from, again, things like automobiles. So we are definitely moving in the right direction. Although I think back to the 80s when, and even the 70s when the push to recycle started, and how slowly we've been moving. You know, why are we only at 49% of aluminum cans? Why aren't we at 100% of glass and aluminum and steel and paper? Again, I think the bottom line is either it's cheaper not to, or we're just too lazy to make the effort to do it. Again, plastic tends to be one of the biggest challenges. The book quotes about 12% of containers and packaging in the U.S. Contained recycled plastic. 37% of all recycled plastic is used in the process of making things like carpeting, auto parts, the felt on tennis balls. Again, only 12% of containers and packaging in the U.S. that are plastic are recycled. 88% are thrown away. Now again, some of that is not a type of plastic that's readily recyclable, but other is recyclable and just isn't. And it's kind of a function of the economy, which ultimately means how much petroleum is. Sometimes it's cheaper to make plastic from raw materials, and sometimes it might be cheaper to recycle plastic. If the price of petroleum's low, then it's cheaper to start from scratch. If it's up, then it may be, different case. The other challenge is that there are almost 50 different types of plastics that are commonly used, and many are mixtures of plastics, which again may or may not be recyclable. And therefore all of these plastics have to be separated out before recycling can occur. Tires used to be a problem. I guess I should say they went from not being a problem, because we just burned them before there were air pollution issues, to being a problem. How do we store these things? What do we do with them? To now basically retreading them, so basically refurbishing tires. And I'm not talking about just like a the tire shop in town, putting new caps on your tires. Basically tires that go back to a complete manufacturing process where they are fitted with a completely new tread system, and it's every bit as stable and good as a new tire, but yet it can be a little cheaper. But then otherwise, tires can be reutilized for playground equipment, trash cans, garden hoses, asphalt for pavement. Other products like, again, what are tires? They're rubber and they're petroleum products. So anything that has those components, tires could be a part of that. Carpets, roofing material, and there continues to be tons and tons of research into developing other products, other ways of utilizing tires. They are also still burned in incinerators to produce electricity. But again, they aren't just burnt in an open situation where those toxins are just emitted to the atmosphere. Those byproducts are captured and scrubbed out of the emissions. So kind of like it's the best practice to use an integrated pest management plan in managing a farm. Using an integrated waste management program is really the combination of all the best practices and techniques that we use to effectively deal with solid waste. So this involves minimizing the waste to begin with, and then preventing the waste by reducing the amount, reusing it, and recycling it. Again, using whatever combination of those things best fits the situation or the waste that we have to deal with. So this, again, simplified figure shows kind of how this process might work, from the raw materials through the disposal or reuse or recycling of those products. There are some type of solid wastes that are classified as hazardous or toxic, because basically these are things that are extremely reactive, corrosive, ignitable, or so toxic that there basically isn't any really good way of getting rid of these things. They only account for about 1% of all of the solid waste, but again, they are disproportionately dangerous, whether it's to the environment or directly to human health. They can be in the form of solid, liquid, and gas. And there are about 700,000 different chemicals that have basically unknown levels of toxicity. We don't know how they'll react with other things as they're being disposed of. And so they basically are stored long-term, forever in other words, and that's simply to get them out of the waste stream. The book talks about the Love Canal disaster, basically a chemical company back in New York that covered a toxic dump with soil and then donated it. The school board didn't really know exactly what was going on or how dangerous any of these, chemicals might have been. The waste from that abandoned dump then leaked out of the landfill, contaminated the entire neighborhood. People, because it got into water, it got into the environment in a variety of ways that basically put people directly exposed to it. 700 plus families had to be evacuated. And basically, I guess the one and only good thing that came from this was it led to the creation of the Superfund Act, which basically held polluters accountable for every penny of the cost to clean up these types of spills or toxic chemicals that were leaked into the environment. Again, prior to that legislation, that there was no particular way that the people that were responsible could be held accountable. And so again, from a very bad situation, at least something good did come of it. So there are a variety of types of hazardous waste products. Hazardous chemicals include a variety of things like acids, dioxins, explosives, heavy metals, infectious waste products from hospitals, gases that have neurotoxic sort of effects, solvents, PCBs, which are byproducts from manufacturing, pesticides, and radioactive substances, just to name maybe some of the more common. I'm not going to go through and kind of read to you each of these, so just kind of review the characteristics of each of these categories, kind of where they come from, how they can get into the food web, what types of problems they cause, and how we might deal with these things, storage-wise or cleanup-wise. So again, the book goes into more detail about the dioxins, about the PCBs, which are actually a group of about 209 chemicals. So it's not just one thing. It's a category of about 209 different chemicals. And then your book also talks about handling nanotechnology. Nanomaterials, which are by definition things that are so small that they're on the scale of nanometers. And these are unique materials and devices that are at the scale of atoms and molecules that are being investigated and studied for uses in medical treatments, sort of like being able to send a little attack vessel into your body to be able to go after cancer, for example. The technology also being investigated for different ways to utilize solar panels for making electricity, heat-resistant glasses, etc. Lots of different things. And there's also, with this technology, concern about health and safety risks. Things that are so infinitely small that you can imagine it would be really easy for them to get into the living tissue of a plant or an animal. And if that were to happen, what type of side effects could that have? People are even concerned about it being able to sort of act like a living thing and adapt itself to the environment, sort of escaping from captivity, if you will, and then having any number of weird things that it can do to the environment. So the EPA, the Environmental Protection Agency, has basically adopted the precautionary approach with respect to nanotechnology. Basically, they're putting the burden of proof that this technology is safe on the companies that are selling it. So they're making them prove that it's going to be safe before these types of products will be able to be integrated. So if we have a chemical accident, some chemical that it's a protected or hazardous chemical gets accidentally dumped in the environment. So let's say we have a train that's transporting chemicals, and there's an accident, the train falls off the track, and the container leaks. Basically, we have this National Response Center, which provides coordination on the site of the incident, where they determine how big the incident is, what the actual chemicals are, how hazardous the situation is, the nature of the accident, any other environmental issues. Is it close to a river? How quickly could that chemical get into the river or the groundwater? So all of those things, there's a very quick response, and all of those things are addressed as quickly as possible. And then the appropriate cleanup or containment procedure is taken into account. We've had chemical safety programs for quite some time, and they've traditionally focused on mitigating the accident, and now more recently the focus has become how do we avoid the accident, preventing the accident. Just one example, with the number of fairly large oil spills we've had with the oil tankers, the big ocean-going vessels that haul petroleum from where it's sucked out of the ground to where it's needed. Because of the number of accidents, the requirements are for multiple thicknesses instead of just maybe single thick hulls. And rather than just having a few really large partitions, now you have to have a bunch of partitions. So that in the unlikely event that an oil tanker actually broke open, that the several layers of protection all failed, that only a small amount of the total volume of petroleum could actually leak because it's stored within multiple baffles within the oil rig. But again, we those kinds of things now are the focus. Let's find ways to prevent these chemicals from being able to get into the environment. The idea being, that we need to redesign transportation and industrial processes so that these dangerous accidents, where we have potentially really hazardous materials, are less likely to occur. So again, it makes sense, clearly, that the more we can prevent something from happening, the better off we are, rather than, oh my God, it's happened, now what do we do to clean it up? So the Resource Conservation and Recovery Act that was passed by Congress in 1976 basically instructed the EPA to identify which wastes are actually considered to be hazardous, and then provide very specific guidelines and standards for how the hazardous waste programs are administered, and therefore requires these hazardous wastes to be treated in such a way that meets the standards of reducing their toxicity before they're disposed of in a landfill or in some other type of long-term storage. It also, the reform in 1992 basically encouraged that hazardous waste recycling occur as much as feasible or possible. Part of this led to some of the things that we've had to do around the college in the past 5 or so years. Any building that contains what is classified as hazardous materials, So obviously, the buildings where the chemistry labs and biology classes are have to have material sheets available to anybody that wants to read them, to know exactly what types of chemicals might be in the building. And then those sheets also have to include how those materials are to be disposed of, how somebody would be treated if they were exposed to that chemical. So we had to basically do a lot of labeling and sort of educational type of stuff, making that information available, in other words. So the Superfund Act then is basically a comprehensive environmental response, compensation, and liability act that deals with waste produced in the past, not currently. So this is all the stuff that we now know is hazardous, that was produced prior to 1980 and is stored or was dumped in abandoned and in inactive waste sites. And we know that at a lot of these sites, the hazardous waste products that have been dumped have actually gotten deep into the soil, or even have gotten down into the groundwater and polluted it to various degrees. Just one example of that. In the Bay Area, I don't remember exactly what city, but there was a facility that I'm not sure what all they manufactured, but basically they manufactured products like jet fuel. And one of the highly hazardous byproducts of that is a compound called perchlorate. And so after that area was abandoned, it was kind of forgotten about, but perchlorate migrated through the environment, through the soil, down into the water, and there were a number of wells that had to be abandoned because they were contaminated with perchlorate. Again, once a chemical gets into the groundwater, there is virtually nothing we can do other than just wait for it to naturally degrade. And keep in mind, some of these hazardous waste products, for all purposes, may never degrade. They may be around for thousands of years. The inventory of these sites currently is about 10,000 in the U.S. And of these, the ones that have the greatest potential threat are placed on this priority list, the Superfund National Priority List. And then basically there's money provided by the government, and they assist with these areas being cleaned up. Again, sort of a priority list from the worst sites that obviously get the highest list, so that they can be tackled sooner. And we are unfortunate to have one of these in the Redding area. The Iron Mountain Mine is on the Superfund site, and that's why there has been a lot of work in recent decades trying to deal with cleaning up and keeping the hazardous waste from, in the future, getting out. So certainly the most effective approach is to reduce the source. And this is accomplished in one way by what's called green chemistry. Basically processes that have been redesigned to significantly reduce the hazardous materials that are produced. Therefore, when these materials are exposed to the environment, they are far less hazardous or non-hazardous, and therefore don't create the sort of environmental damage that was created in the past. So that's the best approach. Second best approach is to find ways to reduce the toxicity of those materials before they're stored. And there are chemical ways of doing this, biological and physical ways. Incineration is a physical way of potentially reducing the toxicity, or at least the volume. But the downside is that the ash is still hazardous, so it still has to be stored, but at least then there might be less volume, even if it's still toxic. And then the third option is ultimately things that cannot be detoxified or have their toxicity reduced go into long-term storage. Specific toxic waste landfills, or using abandoned mines where barrels of toxic materials are stored underground, in theory, forever. Certainly, toxic landfills are subject to strict environmental criteria because of how dangerous or potentially dangerous these materials are. And then even any material that leaches out of these areas is specifically collected, and then every effort is made to detoxify that material. Sometimes there are toxic liquids that are injected in deep underground wells that are located between impermeable layers of rock. There's really a lot of concern about this because certainly, even though those are impermeable layers, does that mean they could never spring a leak? Layers of rock can shift, because of seismic activity, geologic activity. The plug that's used to plug the hole after it's full of waste certainly has the potential to fail. So there are some concerns about that option. And then again, an image of what a hazardous waste landfill might look like. Notice at the bottom, not only the collection system, but there are detection systems in place, monitoring. Because again, once this is covered over and revegetated, the only way you're going to know if there's a leak is if you've got a monitoring system, instruments in place down in the bottom of this landfill. So again, if one of those barrels were to leak and then material leaked into the surrounding area, those sensors should pick it up, and the drains should then be able to collect that material, where either it gets put into a new container and stored in a new area, or potentially maybe it can be decontaminated. And then finally, a case study on high-tech waste. If you look at products that we in the developed country probably buy and throw away more than anything else, it's going to be the high-tech stuff, the electronic devices. Again, on average, computers are replaced every 1.5 to 2 years. And again, not because they're broken, just because the technology is advancing so quickly, we feel like we just, we got old, worthless computers if they aren't the newest version. So frequently in the past, they've just been thrown away with household garbage and then ultimately go to a landfill. Huge amounts of plastics, metals, including toxins, would have therefore been dumped in landfills. To address that, we're using different types of compounds now. LCD monitors have a lot less lead than other older technology, fewer heavy metals, although cadmium, mercury, copper, tin, palladium are still present in electronics. And even though now we recycle more of our electronics, we call it e-cycled, that's only about 25%. a lot of these are actually shipped overseas, or either they're recycled, and then the useful metals can be recovered and reused. Or in some cases, they may simply be reused as the whole computer or the monitor or whatever might just be used because it's better than what they got. But again, that's still only 25%. When you buy a new TV, you're actually paying a little extra money, and you may not even have noticed or been told it, but you're paying a little bit of extra money because of the cost of e-cycling that TV when you throw it away or when you turn it in, to get it replaced. Companies are now offering rebates or a little bit of money if you turn in your computer when you buy a new one. I know Dell, the last time I bought a Dell computer, which I actually have an Apple now, but the last Dell computer I bought, they gave me, a rebate of $25 or $50, something like that. If when I got my new computer, I packed my old one in the box and then mailed it back to them free of charge, they paid for the shipping. And so what they would do is take the parts out that they could reuse and then, recuperated some of the metals and things before whatever was left would have been, taken to a landfill. So, again, there's a lot more e-cycling going on now. And in some places, it's actually mandatory, although people still throw things away in their garbage cans because they don't care. They know they won't get caught. They don't want to have to pay the money to recycle something. But again, there's the transfer station in Reading that most cities have, where you can take electronics and dispose of them properly, as well as other hazardous things that you might have around your home, like old paint or garden chemicals that you don't use anymore. So please take advantage of that. Don't throw those things in the garbage. There are ways to get rid of those things that don't cost money. Again, the incentive is they don't charge you so that you do the right thing, that you take those things to a place where they can properly dispose of them.